Welcome back to Computer Organization course. Today we will discuss continuous part of interrupts. In the previous video, I had explained the basic mechanism of interrupts in a primitive level. Today we will study few more topics regarding interrupts. This interrupt part 2 video includes basic idea of how hardware is implemented in order to implement interrupt theory concept. Then we will discuss how to enable or disable interrupts from the devices, and also we discuss whatever different events occurs when a particular interrupt is appeared. Then handling multiple devices, that means there will be many input output devices in the processor connected to the processor. So processor has to handle interrupts from multiple devices. So we will discuss all these topics in this video. So let me explain interrupt hardware at the beginning. So here we will discuss what are the hardwares required to implement interrupt concept. Now we require two signals here. Okay, so signals are nothing but physical wire which can carry logic from one side to another side. That means we also call it as lines, physical wires, or signals. So if I supply plus 5 volt on this side of a logic wire or a signal, so another side it will become plus 5 volt. It carries that signal. So plus 5 volt is nothing but one logic 1, right? Here also it will become logic 1. If I supply 0 volt, that means logic 0. Then another side also it will release logic 0. Okay, so now so this is a concept. Signal means a physical wire. It carries logic 1 or 0 based on plus 5 volt or 0. Now you can see here there is a bar over both the signal. Okay, that means these are active low signals. Now what are active low signals? Just introduce a NOT gate here. Now what happens? So if I supply plus 5 volt, that means logic 1 at this side, here it becomes logic 0. If I supply 0 volt, that means logic 0, on this side it becomes logic 1. So now it is called active low signal. That means if there is a device here, okay, and that device makes some activity when it receives signal 1, and it stops activity when it receives signal 0. So how to activate that activity from this device? Means you have to supply 0 here. Why? When you supply 0 here, at this end it will become 1. So device thinks you have sent 1, so it starts the activity. To stop it, I have to send 1 here on this side. Okay, I will make it high, and here it becomes 0. So signal thinks you want to stop the activity. Means 1 and 0 is nothing but high and low. Okay, so to start a activity we have to make signal as low, right, 0, so that here it will become 1. So that's why it is called active low signal. Now let us see how INTR works. Now what is INTR? It is interrupt signal. Interrupt signal, this is signal used by the devices to interrupt the processor, to inform processor that I am ready. So now how it works? It is anyway it is active low signal, means inside the processor there will be a NOT gate here, right? Okay, and imagine this is I have connected to continuous plus 5 volt, that is nothing but VCC, we call it as VCC, right? So that is plus 5 volt, so it is always 1. Here logic is always 1. Okay, so that here logic is always 0 when the signal reaches to the processor is 0. So processor thinks this is a INTR line, so processor thinks no interrupts, it keep executing its regular work. But if a device like this keyboard wants to send an interrupt, then it will ground this signal. What happens when signal is grounded? This one logic, that is plus 5 volt, will go to ground, and immediately the signal becomes 0. If this signal becomes 0, here it becomes 1. So when its signal becomes 1 into the processor thinks there is an interrupt. So who grounds this signal? The device which wants to interrupt. So grounding the signal that means device is sending interrupt signal to the processor. Now what happens when there are multiple devices? So now when there are multiple devices, for example there is a keyboard, there is one more input output, there are multiple input output devices. Okay, that same line is connected to all the devices. See, one single signal line, interrupt request line, it is called interrupt request line. Okay, the same interrupt request INTR line is connected, and that there will be a switch given to every device here to ground the signal. So now what happens, I'll name it as 1 2 3. Okay, so VCC, that is INT is connected to here VCC, so always it will be 0, thinking processor thinks there is no interrupt. Whenever a particular device, like if for example interrupt device 2 here, device 2 wants to send a interrupt request signal to the processor, then device 2 grounds this signal here using this switch, grounds this signal. So what happens, this plus 5 volt will go to ground now. So immediately this signal becomes 0. So after not yet, now it becomes 1. When it is 1, signal is 1, processor comes to know that a device has interrupted its, a device is requesting an interrupt. So this is how devices interrupts the processor, just using interrupt request signal, which is active low, and it is a single signal to all the devices. Now you can easily understand, when it is 1, processor comes to know that interrupt has been requested by a device, but processor never comes to know that which device, because 1 2 3 all the device, any device grounds the signal, it will be 1 on the processor side, but processor can never find out which device has interrupted. For that there will be different mechanism, we'll study later. This is the diagram given in your textbook. Okay, the same thing I have explained you. So this is INTR1 means this switch will be there with the input or output device 1. This is input output device 2, or this is 3, or something like that. So a particular device will press the switch, okay, and grounds the signal. Then this interrupt signal becomes 1 here. Initially it will be 1 only. When it's grounded it becomes 0. Here this is active low signal. So processor, at the end of the processor it will becomes 1, and processor comes to know that there is some interrupt. Some device is requesting the interrupt using INTR active low signal. So now when I say processor, a particular device presses switch and grounds it, this is just for convincing you. No devices directly press a switch. It is just a mechanism. Now let us see INTA line, interrupt acknowledgement line. Just like interrupt request line, INT line also active low signal. That means processor and then a NOT gate, it will be there inside the processor itself. Then it is connected to every device. Okay, for example here only one device I have taken, I will take one more device. This is connected to the device. So initially it will be 0 at the beginning. No interrupts are requested by any device. It will be 0. I am talking about INTA acknowledgement. So for every device it is 1. Every device reads this signal as 1, and it is taught to the device that when the signal is 1, that means there is no acknowledgement from the processor. Now a particular device uses INTR line, grounds it, and sends interrupt request signal to the processor, and now processor accepts that interrupt. Then processor has to acknowledge the device that interrupt has been accepted. So how processor informs the device about accepting the interrupt? As soon as interrupt is accepted by the processor, processor makes this signal INTA signal as 1. That means another side of the AND gate it becomes 0. So for every device it reaches 0. So that any device which has requested the interrupt, it comes to know that I had requested an interrupt through INTR. Now INTA line becomes 0. That means interrupt has been accepted. So this is INTA line. This is about interrupt hardware. They have discussed in your syllabus. So now enabling and disabling interrupts. So first of all, why we want to disable an interrupt? So interrupts are there so that any device can inform processor that it is ready to receive the data or to send the data based on the input or output device. Now why processor want to disable device interrupts? That means process, there will be many reasons. Okay, main reason is what happens is when a particular device has interrupted the processor, and processor is answering that interrupt, means executing the interrupt service routine of that device. That means processor is communicating to that device. Then processor don't want any other device to be send interrupt signal. As long as processor serves one interrupt, that means as long as processor executes interrupt service routine of a particular device interrupt, right, then processor do not want any other device to send interrupt signal. Once one ISR, interrupt service routine, is executed, that means once a interrupt is answered from a particular device, then processor can take one more interrupt. During answering or during execution of interrupt service routine, processor don't want any other device to send the interrupts. That time processor want to disable it. While answering one interrupt, processor disable interrupt from all other devices. So that is the thing. Now how it can be done? So there is a one method discussed here using instructions. So here in the processor itself, there will be two instructions implemented. One instruction is to disable the interrupt and another instruction is to re-enable or enable the interrupts. So now what happens is, in the every interrupt service routine, first instruction will be interrupt disable and last instruction of the interrupt service routine is interrupt enable. So what happens when a processor executes an interrupt service routine? The first interrupt is instruction is interrupt disable, means as soon as interrupt service routine starts executing, first instruction itself disables all the interrupts. Then that interrupt service routine is executed and last instruction is that interrupt enable. So last instruction of the interrupt service routine enables the all interrupts again, and that interrupt service routine is over, execution is over. So this is how we can use interrupt enable and disable instructions inside the interrupt service routines only. Okay, so if suppose keyboard interrupts the processor and processor is executing keyboard's interrupt service routine, first instruction it disables the interrupts. So no device can now interrupt, including keyboard itself. Okay, all interrupts are disabled. Then that in remaining part of the interrupt service routine for keyboard is executed. The last instruction of that interrupt service routine is interrupt enable. Now all interrupts are enabled and interrupt service routine for keyboard is executed. So now other devices can interrupt or same device can interrupt. So this is how we can disable or enable interrupts and why it is required. This is the important part of this session in exam point of view as well as to understand entire interrupt concept. Here now we discussed sequence of events which happens when a device interrupts the processor. What are the different things happens step by step? So when initially a device raises the interrupt request, that is using INTR line, okay, that line is grounded by the device so that INTR line at the processor becomes 1. So this is how it raises the interrupt. Now when processor reads that signal as 1, INTR signal as 1, processor stops program that is being executed. Whatever the program processor is executing, it stops it there. Okay. Then processor disables interrupts. Why? One interrupt is being answered now. No? So that's why it disables interrupts. No other devices or that device itself again interrupt it, because currently processor is answering the interrupt. Now processor uses INTA line, that is interrupt acknowledgement line, to inform device that your interrupt has been accepted. Once that INTA interrupt acknowledgement is received by the device, then device deactivates INTR line, that is we said in step 1, right? So INTR line is grounded by the device. So at the processor side it will be 1. Now once the response is received from the processor to the device, that is using INTA line, once the processor acknowledges the device that your interrupt has been accepted, then that device ungrounds INTR line, interrupt request line, so that at the processor side the interrupt request line becomes 0. Otherwise it will be irritating processor, right? It makes processor think that there are continuous interrupts. That's why once acknowledgement is received, device makes interrupt request, deactivates interrupt request line. Now processor executes the interrupt service routine based on which device has interrupted. Once that interrupt service routine is executed, that means processor answered the interrupts, or once the communication is done with the device, that is nothing but interrupt service routine execution. It's executed, then processor enables the interrupt once again. So these are the step-by-step events happening when an interrupt occurs at the processor. Handling multiple devices. Till now I explained you various concepts of interrupts, but one concept, that there will be a single INTR line, interrupt request line, for every input output device. Whenever that line becomes 1 at the processor side, processor thinks that some device has interrupted the processor. There is an interrupt request, but processor will never come to know that which device, because there is a common interrupt request line. Processor cannot understand which device has interrupted. So here multiple devices are there, that is the issue. Now when there is a multiple devices, okay, for which interrupts the processor, there are some question arises that we can understand that question very easily. See, when a interrupt is requested using a common interrupt request line, then how processor identifies which device has generated the interrupt? Next, second question is, when a particular interrupt occurs, processor has to execute a particular interrupt service routine. For different interrupts from different devices, there will be different interrupt service routine to be executed. So how, when an interrupt occurs at the processor side, how processor identifies which interrupt service routine has to be executed? Because every interrupt service routine is stored in separate addresses, different memory, right? So which interrupt service routine has to be executed? That is one more question. Now one more question is, if currently one interrupt service routine is under execution, means processor is answering one interrupt, can processor allow any other device or the same device to interrupt once again? We recently, just now we studied that there is interrupt disable instructions. Processor do not allow other devices or any devices to interrupt it when it is already answering one interrupt. Okay, so still the question will be there, whether processor has to allow other devices to interrupt the processor when currently interrupt is being executed. And the last question is, what happens when two devices request interrupt at a time? That means common interrupt request line is there. Two devices grounds the line at a time. Two devices, at a time. So at the processor side it will be one, interrupt request line will be one. Processor comes to know that there is an interrupt, and even if processor identifies which device, processor comes to know that there are two devices simultaneously. So how to solve this issue? Whose interrupt first should be answered first? So there must be a strategy. So in this session we do not answer all the questions. Here in this session we will try to answer first two questions. Okay, how processor identifies which device has interrupted it and which interrupt service routine should be executed. Thus we will study strategy about that. Now when interrupt occurs at the processor, how processor identifies which device interrupted it? Because there is a common interrupt request line. Processor uses a simple technique here. We know that in every input output device there will be IO interface. In the IO interface there will be different registers like S in register, S out register, data in register, data out register, also status register. In the status register there is one bit is reserved, only one bit is reserved as IRQ bit. In every IO device there will be a status register in its interface. In that status register of every IO device, one particular bit is reserved as interrupt request bit, and this bit is always 0. When a particular device interrupts the processor, that makes bit as 1. It makes interrupt request bit as 1. But this bit will be there in every IO device. Now what happens when interrupt occurs at the processor? Processor go to every device and check its status register. In that processor check IRQ bit. Every IO device is checked by the processor one by one. So go to IO device, number 1 IO device, go to its status register, find out IRQ bit and see whether it is 1 or 0. Then go to another IO device, then again check IRQ bit of that device whether it is 1 or 0. So how many IO devices are there? Every device the processor has to go through and check its IRQ bit. But it is the responsibility of devices when it requests interrupt, devices has to make IRQ bit as 1. Now by doing this, right, checking status register of every IO device one by one, processor can identify which device has requested the interrupt. This is the one thing. Now what happens, two devices or more than one devices has requested interrupt at a time? That time processor finds out that IRQ bit will be 1 in multiple devices. Correct, no? All the devices which request interrupt makes IRQ bit as 1. When multiple devices requested the interrupt at a time, then all IRQ bit of those devices of IRQ bit will be 1. So processor finds out multiple devices with IRQ bit 1. Now how to handle multiple requests? Processor can execute any one interrupt service routine at a time. So now there is a concept called poll. Poll is nothing but in general we call election. What is election? When there are multiple options, we select a particular, for example, political elections. So there are multiple candidates, we select one candidate out of this, out of options. So similarly here polling means when processor finds out IRQ bit equal to 1 in multiple devices, that means when multiple devices has requested interrupt, processor selects any one device. It is called polling. Now there are various ways of polling. Okay, for example, if you want to elect a one person out of 10, so you can go for voting method, or you can go for height wise. Who is the heightest person, you can select them, or you can go for weight wise. Who is having higher weight, you can select them. So polling is similarly in IO devices also we can have different polling mechanism, but here processor can use a simple polling mechanism. Okay, what is that? See, when multiple devices request the interrupt, those devices inside their status bit makes IRQ bit as 1. When interrupt is occurred at the processor go through every device and check whether IRQ bit in that status register is 1. Now processor stops this searching when it finds out a device's IRQ bit is 1 and do not go further. That means out of 10 IO devices, if third IO device has requested the interrupt and seventh IO device has requested the interrupt, processor check first IO device, then go to second IO device and then go to third IO device. First and second IRQ bit is 0, they have not requested interrupt. Third device has requested the interrupt, so its IRQ bit is 1. As soon as processor finds first time an IRQ bit as 1, processor executes its interrupt. Processor executes its interrupt service routine. So what about one more device, the seventh device? No. Processor polling mechanism is very simple. That whenever there is an interrupt, it check IRQ bit of every device one by one, as long as it finds a IRQ bit as 1 in any device. First time when it finds IRQ bit equal to 1, it executes that particular interrupt service routine related to that device. So this is there are so many disadvantages of this simple polling mechanism. One important disadvantage that we discuss here, time consuming. Because when interrupt is requested, processor has to go and check every IO device's status register and find whether IRQ bit is 0 or 1. and there are many other disadvantages that we will study in further sessions. So this is about how processor identifies a particular device, as well as how processor handles multiple requests from two or more devices. Now let us try to answer one more question, that is, when a particular device requests the interrupt, there will be multiple interrupt service routine stored in the memory. How processor recognize which interrupt service routine has to be executed when a interrupt is occurred? So if keyboard interrupts the processor, interrupt service routine related to keyboard only should be executed. How processor identifies which is the interrupt service routine, where it has been stored? Because to that interrupt service routine, program counter has to be updated. So this is, in this video or in this slide, I am answering that question. Okay, how processor identifies which interrupt service routine has to be executed when a particular device interrupts the processor. Or indirectly I can say, how processor finds out memory address of the interrupt service routine related to a particular interrupt when interrupt occurs. So this is very simple. See, initially when processor interrupts the initially a device interrupts the processor. Then if we make device itself to send a particular special code, or some code to the processor, using that code processor can identify where exactly interrupt service routine related to that particular device is stored in the memory, or which interrupt service routine has to be executed. So device itself sends a code to help the processor to find out ISR, interrupt service routine. Now I'll explain this using a diagram. So this is how our interrupt hardware mechanism looks like. So there will be interrupt request line, the signal sent by the IO device to the processor to request an interrupt. Then there is a INTA line, interrupt acknowledgement line, which is used by processor to inform IO device that its interrupt has been accepted. Then what is the meaning of execution of interrupt service routine? That means if it is the key input device, for example keyboard, executing interrupt service routine of keyboard means processor fetch data collected by the keyboard through data bus and utilizes that data. Now what is the meaning of execution of interrupt service routine for an output device? See, when output device requests an interrupt, processor acknowledges the output device saying your interrupt has been accepted. Now what is the meaning of ISR execution, interrupt service routine execution for output device? That means processor has some data, it will be copied from data bus, through data bus it will be sent to the output device, so that output device can give it to the user. So this is meaning of execution of interrupt service routine, transferring data from processor to output device or from input device to the processor. Now how a special code concept works to identify interrupt service routine? The concept is very simple. When IO device requests an interrupt, processor acknowledges the interrupt. That time IO device sends a particular code to the processor to help to find out interrupt service routine. Now that code cannot be sent through INTA or INTR line. Why? Because these two lines carries single bit information, right? 1 or 0. We cannot send a code, okay, which has multiple bits. So that time once the acknowledgement is received by the IO device from the processor, that acknowledgement is received by the IO device uses data bus to send the code, the special code which helps processor to find out interrupt service routine in the memory. Now let us see this in little bit detail. So now we will come to vectored interrupt concept. So this was the topic we are discussing, vectored interrupt. First of all, what is vector? In programming language I can say vector is nothing but array. Right? We know array. Array is nothing but continuous arrangement of memory where every cell of array has an index. 0, 1, 2, 3, it starts from 0, has index. And within every cell we can store some data. So this is a very basic knowledge of programming language. What is array? So vector means nothing but array. So how array is used in the interrupts? So question is how whenever a device interrupts the processor has to find out its interrupt service routine in the memory to execute that particular interrupt service routine. So let us see, this is a main memory. First interrupt service routine, let me assume this belongs to keyboard. Second interrupt service routine that has to be executed when display interrupts the processor. Third interrupt service routine that has to be executed when printer interrupts the processor. So similarly, there will be multiple interrupt service routines stored in the memory for different devices. Now what happens is there will be an arrangement vector or array where starting address of every interrupt service routine is stored in that particular array under every indices or index 0, 1, 2 of the array. Now I told you that whenever a device interrupts the processor, device itself sends a special code to help processor find out interrupt service routine in the memory. Now what is that special code? That is nothing but the address of these particular places in the array. That means the special code sent by the device when it requests the interrupt is nothing but index of the array where its interrupt service routine starting address is stored. To be very clear, I'll take the example. Suppose display interrupts the processor. Processor acknowledges the display saying that your interrupt has been accepted. Then display using data bus sends special code called 1. 1 anta kalisuttadu data bus alli. When processor receives this special code 1, processor comes to this vector or array and finds out what is the address is there under that index. Processor copies that address to PC register. What happens now? PC directly points to the starting address of that service routine. So PC is nothing but that instruction that has to be executed next. So processor starts executing this interrupt service routine and at the end it returns to the program which has stopped in between. Now what happens? We'll take one more example when keyboard interrupts the processor. When keyboard interrupts the processor sends the acknowledgement to the keyboard and keyboard sends its special code as 0 because it is already thought to the processor that keyboard that okay, your special code is 0. Now that special code is received by the processor 0, processor directly come to this vector, finds out what is the address stored in the that particular special code or index 0 and copies that address to the PC register. So PC register points to that particular address. Processor executes that interrupt service routine and go back to the program which is stopped because of interrupts. So it is overall I can say when a device interrupts the processor, device itself sends the index special code, that is nothing but index of the vector or array where its starting address of its interrupt service routine has been stored. So by like this using vector, processor finds out whenever an interrupt occurs, processor finds out which interrupt service routine from the memory has to be executed. This is called vectored interrupts. So this was video about interrupts. It's part 2 video. First video I have already uploaded. This is the second video about interrupts where we discussed right, already we have discussed mechanism of interrupt, basic mechanism already we have discussed in part 1. In part 2 we discussed that hardware required for interrupt execution, that is nothing but INTR, interrupt request line and interrupt acknowledgement line. Then we discuss how to enable and disable the interrupts using interrupt enable disable instructions. Then what is the necessity of enabling disabling interrupts. Then we discuss sequence of events happens when an interrupt interrupts the processor by the device. So that is very important, okay, in the point of exam. Then we discuss how to handle multiple device interrupts. Right, one thing we discussed here is how processor identifies which device has interrupted it. Then one more concept we discussed, polling, that nothing but how processor selects one device which has interrupted when more than one device has actually interrupted. There are more than one device has interrupted the processor at a time, but processor uses polling and selects one device. Then we finally studied vectored interrupt technique. So this technique is used to identify which interrupt service routine has to be executed, or address of the interrupt service routine which is stored in the memory for a particular key input device or output device. That means when a input device or output device interrupts the processor, how processor finds out which interrupt service routine has to be executed from the memory. That is solved using vectored interrupts. There are few more concepts are remaining interrupts. I'll explain in one more video, part 3. Thank you.